Thank you. I share my presentation with Veronica Arcas. I try to introduce the Fertile City project, first of all, and another project where we are involved with, that is Putti, and Residual Garden at the last part, the greenhouse to reduce CO2 on rooftop. That is the part that will be introduced by Veronica Arcas. Okay, so where we are here in Barcelona, in Spain. You can see here we have our building. This is a building that was built in 2014, so 6-7 years ago. And on the rooftop, we have a greenhouse. What we are doing, so here in this greenhouse or in the rooftop, we have different urban agriculture labs. And this is on the right side. This is a picture what we are doing. So, what is the characteristic of our building? So, our building, as you can see, is we explain that it's an eco-designing building. So, inside the building, we try to reduce energy. We try to reduce water consumption and all the resources. And how do you do it? This is what I try to show, but I will focus on the food production in the rooftop. We thought that this is the first rooftop greenhouse integrated in the building. And I try to show what that means integration inside the building, because we talk about the flows. So our objective is to move from the linear conventional agriculture to a circular urban agriculture. So we are in the circular urban metabolism framework, and our objective is to use all local resources to produce food and also local consumption of the food produced. So this is a diagram with the flows. As you can see, all the water that we use comes from the rainwater. So this is a local source, not only for the food production, also inside the building, except for the legal purpose that we need, or we have a fountain in each floor. At the same time, we reuse in the rooftop the energy or the flows that contains the embodied energy contained in the flows from inside the building. And in the last step, also flow from the rooftop can go to the inside the building. So that allows this to produce in the rooftop food, tomatoes, lettuce, beans, and others, depending the experiment that we are doing. In fact, we have two models of urban agriculture labs, each one of about 100 square meters. Well, this is a picture of what we produce every year. Every year we are producing more than 1,000 kilos of tomatoes during the summer season. This is our tomatoes in the rooftop, or beans. So our objective is also to do a quantitative analysis. What is the advantage to have this greenhouse integrated inside the building on the rooftop? So on one hand, during the day, and a conventional production, we can have there extreme temperatures for crop production. So we are in Barcelona, that usually in summer we can reach 35-40 Celsius degree. But what happens in our rooftop greenhouse that is integrated? Usually, so the building has an effect inside the greenhouse, and usually this is, or we have lower temperatures. Also in the night, we have an inverse effect in the night during winter, where we have extreme temperatures outside the building, about 1, 2, 3, 4 Celsius degrees. But as the building has an inertia, we can maintain during winter in night inside the greenhouse our greenhouse in a low temperature. And also we have done experiments using the CO2 from the meeting room, conference rooms that is moved inside the greenhouse in order to improve our production. This is a picture where I try to show what the energy saving between the greenhouse in the rooftop and the building. So we have accounted the flows from the building to the greenhouse in red color and the flows from the greenhouse to the building. I want to summarize. Maybe here you can see the numbers, figures in kilowatts square meters for each flow. But the most important is this number. So when this is translated in euros, we are saving with the university, in our case, because the university don't refund us these funds, about 8,600 euros per year. And this is the effect due to the synergy between the greenhouse and the building. And this is one of the main results that I wanted to show today. Okay, also we talked before about energy, also about water. We started, we are in Barcelona, where this is our rainfall. It's not, it's an average 500 liters per square meter, but we have had years with 200 or 300 liters per square meters. Currently, with the recirculation inside the crops, all the production has used only rainwater. For us, it's not only a technology issue, and we have the focus also in the social part. And this is a part of the work that we have done in the social part. I moved to another project called FUTI. This project is a European project coordinated by the Bologna University. And what I want to show here, maybe you are interested, is we have in this project, FUTI, that there are pilots around Europe, and you can check in the web page more information about this if you are interested. Also, we are developing an app in order to obtain feedback from the consumers and also to do a quantitative assessment. This quantitative assessment will be based on social, economic, and environmental KPIs. And at the end, I want to finish part of this knowledge we are transferring through the spin-off that we promoted this company called Teptun Garden, and we usually collaborate with architects, consultancy, and the private sector. Now, Veronica Arcas will explain the advance of the pilots in the GROOF project. Yes.
Hi, everyone. I wanted to talk about the GROOF project. It's an Interreg project from the Northwest Europe region. And we are 11 partners based in France, Belgium, Germany, and Luxembourg and Spain, obviously. And the main point is the use of greenhouses to reduce the emissions by buildings. Basically, we talk about CO2 and heat. And therefore, not only reduce the use of these, reduce these emissions, but also increase the resilience in the urban areas. How do we manage to do this project? So we started in 2017, and we looked at the breaks and the opportunities of these type of installations, because the aim is to develop real pilots to then extract the information from, to see if these flows really can be reduced and if the plants really can benefit from these emissions. And so we started the development of the pilots, and then the idea, the project is still ongoing. And the idea is then to coach other projects that would like to follow up on these initiatives. So we have these 4 pilots. The first one, Pilz, is in Germany. Then we have one in the University of Liège in Belgium. Close to Paris, in Saint-Denis, we have Les Femmes Galliques. And then we have in Luxembourg, in Bettembourg, we have another pilot. All of them, due to the pandemic, of course, it's been really difficult for the construction of them. So they are under construction right now. And I wanted to also speak about the business models of these pilots, because they are very different. For example, the Burstadt, the one from Germany, it's more about a social and community-based space where people go to learn and teach about agriculture and also about energy flows and all these type of things. So it's more social and community-based approach. Then we have the university, which is obviously about research. We have Les Femmes Galliques, which is a mix between production and also social and community based. And the last one, the one in Luxembourg, is more about production. So we have different profiles, which is very interesting for us because of the information that we can gather from that. So we also, as I said before, we are coaching other models, and these models also have they are very diverse and very different, and they are starting right now in different parts of the world, and well, different parts of Europe basically, and they also have very different models and very different objectives. Ones are for research, also are more drawn to education, also social bonding, which are usually communities that live in the same building, which share a garden on the rooftop, or also productive for production, basically. So one of our pilots is the one in Germany, which is, as I said before, the objective is more the reduction of the food chain, local production, local consumption, and basically food hub or community that is more based on the learning and sharing and teaching about agriculture. It's the one that I showed before, the EBF pilot, and it's the design of this greenhouse is from the same company that has this space. And it was an old building of a packaging hall, which is now repurposed to have on top of the greenhouse and also on the bottom an activity that then can, for example, refrigeration or something where they can use the energy and the emissions from the same building for the greenhouse. So I will show you now some pictures of how this construction is going and how it looked before and how it's looking now. So we can see more how the project is going. So this is the packaging hall from the 50s, which is, as you can see, very old. And the construction, when the started like a year ago, I think. And we can see the materials are very I used very carefully because, well, the business EBF is also very based on the use of materials and energy flows. So it's as it's also in Germany, it's very cold, so they are very careful with using very heat capting materials. I don't know if that's the real word. And also using old materials from the building, existing building. We will hear the steel structures starting with the reinforcement of the building, and it's I think it's called a Chinese greenhouse with a wall behind it, so the heat is more contained during the year. As you can see, the wall is starting in the back. And then there is an installation of hempcrete walls to further reduce the heat loss of the building, of the greenhouse. And finally, we have an IfLS film cover to increase the light transmission. So I think that's it. Thank you very much.